I saw a few of you logged on. This is the book that we're doing. We're kicking off with module 2, page 1, which is Confined Space and Excavations. Okay. Okay, great. So here you go, folks. So like we talked about, this is the book that we're using tonight. And good. I see a multi-gas. I see a couple single gases, right? H2S and methane. Okay, great. I'm going to walk you through some internet searches tonight for anybody who's not familiar, and we'll get up to speed a little bit on gases also. Pat, Sue, what are you guys reading for normally? Carlos, what are you guys reading for? Are you reading for oxygen, LEL, H2S, and CO? Is that correct? Are you reading for those 4 gases? Or is there anything different that you're reading for? Yep, those tend to be the most common ones, okay? So great. Folks, for anybody who's not familiar with that, we're going to get you familiar and up to speed tonight, okay? Um, so let's go through the definitions, and then I'm going to get to this page that I just put up on the screen for you. The next one is combustible, right? You know, any type of material or air that can be explosive or can also cause a fire as well. Also, a competent person. We talked about competent and qualified people last week, right? Different and qualified and a competent person. And what's the difference? Let me go ahead. Let me put the definition up real quickly because I want to make sure. And you're going to see we're going to talk about this over and over again. And the reason I'm looking for it now in this one is because competent and qualified persons, the biggest issues are, and let me explain to you where we need competent persons. We need competent persons to do any workplace inspection. We also need a competent person to do excavations, confined space, rigging, scaffolding, and fall protection, okay? So read those 2 definitions really quickly, folks. And the first one is competent person, and the second one is qualified person, just so you know. And both of these come from a letter of interpretation from Osha, okay? Okay, so you see the significant difference, right? And let me explain something, everyone. First of all, a qualified person, everybody has to be trained, and if they have any responsibilities, they're going to have to be qualified. And I'm going to explain that when we get to excavations. I'm going to explain. I'm going to be able to give you a much better explanation of qualified as well. Okay. But let me explain the best that I can right now. Is everybody has to be trained to do their job? Are we all in agreement with that? Okay, good. Okay, good. Every employee has to be trained on how to do the job or the task that they do and in the environment that they do it in. They have to be trained on the task, and they have to also be trained on hazard awareness, okay? And you'll hear me say that over and over again in every session as well because it's that important. Second of all, we have to have certain qualified people. So qualified persons would design a scaffold. Okay, qualified persons would design an electrical system, and qualified persons would design an excavation protective system. Okay, just to give you a few examples. Now, a competent person, it must be done. It must be executed underneath the direction of a competent person. That competent person must be qualified to the level at which they work. So, if that qualified person does, let's say, benching or shoring, right? Well, then they have to at least know how to do benching or shoring or sloping. If that person in certain, it may only be in certain conditions. They may only be qualified to do it in the south, or they may only be qualified to also do it in the north because of ice and cold weather and different dirt conditions. Now, a competent person has to be qualified to their degree of authority, knowledge, but they also have to be competent. What gives them the competency is that authorization to take prompt corrective action. So somebody might design a protective system, right, for like let's say an excavation, or somebody might design a scaffold, but if they don't have the authority to take prompt corrective action and make repairs as it's being built, they cannot be the competent person. Does that make sense to you guys? Okay, great. What about the rest of you? Is that, let me know if it does or if it doesn't, because we're going to come back to it over and over again, just so you know. But bottom line, they both have to be qualified. Okay, the designer must be qualified to the level of designing. The competent person must be qualified to the level of implementing the design. Okay, like the build, right? Assembly, disassembly, but also have the competency and have the authority to take prompt corrective action. Okay. Okay, good. All right, so let's move on from that, and so let's go back to the definitions, and then a confined space, right? A space on a job site where they're considered confined and where they're large enough for bodily entry. They're not made for continuous occupancy, and they have limited means of entry and exit. And the reason I didn't do it in the order of the definition is because we're going to go back to that worksheet that I had in just a second. Okay. Then let's talk about. I'm going to skip. I'm going to skip the rest of them right now, and let's actually go to the sheet because it's going to be a whole lot easier. Okay. Let me actually knock out one more. Look at qualified person. A qualified person, right? A company approved or otherwise designated individual that has the confined space training. Okay. The qualified person does what? They test the air. And they also will go ahead and give us advisories to what hazards to look out for. Okay. They may also design the ventilation that we're going to use as well. And then the competent person is going to implement all of that. Okay. So let me go back to that PowerPoint. Let me go back to that slide that we had. Let me see. Excuse me. Okay, here we go. So here's the slide. We're going to do me a favor, folks, chime in and let me know if you've seen this yet. We've used this a few times already. Let me know if you've seen this or if you haven't seen this, just so I know how fast or how slow I should go on this. Excuse me. Okay, good. Okay. Can everybody read that okay? Is it clear on your end? Okay, good. Okay, great. Okay, folks, so I'm going to cruise this through it pretty quickly because we're going to see it over and over and over again. We talked about it a few weeks ago, and it looks like everybody was online back then. So let me go ahead and kind of push us through it, okay? First of all, look at the bottom left. The bottom left is the OSHA definition of a confined space. In order to be a confined space, it must have three things, right? It has to be large enough to large enough to body owner and for an employee to perform their job. It's got to not be designed for continuous occupancy by the employee. So basically, we shouldn't be eating in it or probably having the safety training in it or having a meeting other than maybe a quick operations meeting of what we're actually doing. But we wouldn't be in there for continuous periods of times. We're not going to probably be lounging in there or anything else. And last of all, it's got to have limited means of entry and exit, kind of like a ladder, climbing a fixed ladder. Steep ramp up or down. Maybe we have to be dropped in with a winch or something. So all different reasons like that. Okay. So that's a definition of a confined space on your left. And then on your right, what you see is if we have a confined space, any of the three on the left, and if it meets any one of the or more of the ones on the right, it's going to make it a permit required confined space. So we'd be classifying this space as a permit required confined space, which number one, it could either contain potential material, right, that may be hazardous to atmosphere. What are we talking about? It could be oxygen deficiency. It could be oxygen enrichment. Also, it could be containing any type of material that may potentially engulf us. Perfect example of this is in a silo, right? Dirt, sunflower seeds, grain, stuff like that. And underground would be maybe excavation that may collapse. Third of all, it may have an internal configuration where we may get entrapped, something like downward slope that's very significant, or maybe converging walls that may be closing up, where we may get pinched in between if we go down too far or too fast. And ultimately, the last one is containing any other recognized serious hazard that might affect our life and safety, okay, or the quality of life as we know it, right? So if it meets any of those four, that confined space we'll have to now classify that confined space as a permit required confined space. All right. Okay. And then also on here, you'll notice things, and we'll talk about it as we go through. There's your responsibilities, folks, as an attendant, an entrant, and a supervisor. And these are all from the OSHA standard. I'm going to actually email this to everybody in the next couple of days. We've got a bundle together that we're getting ready to email you guys. Also, I think we're checking everybody's addresses because in the next week or so, we're going to start mailing out hard copies as well, so everybody doesn't have to print, okay? So we're going to send a PDF to you of this, and I'm going to send you a list of more videos that I'd like you to keep an eye on for confined space as well and excavations, okay? Okay, good. So let me go ahead and move on from this for right now. And then, I'm sorry, one last thing, folks. Look at your left-hand side. Just different examples of what can be considered a confined space. Marine vessels, barges, stationary tanks. I'll show you a list of them too. Mobile tanks, rail cars, inside of rail cars, inside of a tunnel. Normally I'm talking about tunneling, like going underneath a piece of property or excavating underneath a fixed structure is what I'm talking about. Also certain excavations under past 4 feet. Blenders, pits, machines, silos, hoppers, elevators, kilns. A lot of these are in the manufacturing process or the product refining process. Manholes as well, basins, sewer lines, pipes, lift stations, and diked areas. And then, of course, you see a list there of marine vessels as well in the marine industry as well, okay? So just perfect examples, right? Manholes, of course, or it may be a lift station that they're setting up. Here you go, right? And certain pipes, drainage pipes or sewer lines. Also, you'll see the manhole at your upper right. So here's a quick question, folks. Here's a trivia question for you. Can y'all see that manhole in the upper left-hand corner? Okay, good. So here's my question for you. Why are manhole covers round? Take a guess. Everybody's got a guess. I'll give you about the next 30 seconds to a minute to guess. Why are manhole covers round? Okay. Excuse me. Okay, so let me read you. Let me read you the answers that I have. Okay, because the pipe's round, no sharp edges. I don't know. Are all of them round? Okay, look, here you go. Somebody chimed in with the right answer. The reason manhole covers are round is so that the lid will not fall in the hole, regardless of which way you spin it or flip it. Because of the bezel, excuse me, there you go. Because of the bezel around the manhole, no matter which way, in theory, no matter which way you flip this or turn this around, if it doesn't lose its diameter, it should never fall through the hole. Therefore, it protects people above from fall protection, and it protects people below from struck by hazards. Does that make sense? Good. Yeah. I tell you what, we are way safer in public than we often realize. Okay. So good deal. All right. So let's move on from that. Okay. So perfect examples: manholes and pipes, above ground storage tanks, right, or silos, fuel silos. Also, could be on top of it, and it also could be on top of it. The reason it could be on top of it is the same reason. You see this manway here? If somebody, they have to contort their body to go in, right? So it's got limited means of entry and exit. It's large enough for a person to bodily enter and do their job, and it's not made for continuous occupancy. Okay, the same thing. If we climb this ladder here, all right, and get into this landing platform here, and then get into this bird cage going all the way to the top, and we get up here, same thing. All the way on the roof of this vessel right here, of this silo, is also a confined space because we took non-traditional means to get up. We had to climb a fixed ladder. It's not like it's a stairwell. If it was a stairway, it may not be a confined space, but because it's a fixed ladder, it is. All right, limited means of entry and exit, large enough to bodily enter and do our job up here, and not made for continuous occupancy. Does that make sense, folks? Okay. Yeah, and this is the thing, right? One with a ladder is not, but one with a stair rail, let's say if it's got let me show you real quick, folks, for anybody who's not familiar. And then nowadays we see this, right? Correct? Where it's got stairway, a spiral staircase going up. Okay, so this is considered traditional means. So this will most likely not be considered a confined space up here because we have a conventional means to get down, whereas the fixed ladder, like we see in our presentation here, is not conventional means. Okay. Now, let me ask you a question. No less hazardous, right? I mean, the same hazard exists. The only difference is access and exit are much easier. And therefore, now we've eliminated one of the three items of the confined space test, okay? But like I tell people, OSHA even sometimes turns around and says, because it's significant hazard, you should still consider it a confined space, okay? And of course, in your workplace, I guess, you did what your due diligence is, and then you take it. Also, certain excavations and trenchings, if they're greater than 4 feet, it's also going to be a confined space, okay? Inside of pits or equipment, if you can get into processing equipment or pits, it's going to be a confined space. Inside of hoppers, equipment. Now, not just being in this unit up here, because you see guardrails, traditional, you can't see it in the picture, but there's a traditional, you see it here, stairway getting all the way up and down. But once you get into particular units themselves, or now when you get into pipelines, or if there's any kilns in the line that's turning material, any of that would also be considered a confined space. Okay, that's all. Above ground storage tanks as well, processing units as well. I forgot I was messing around, folks. So I don't know if y'all caught that. I left one of our guys in the space. So he'll be really happy that he made the training class tonight when I let him know tomorrow. Okay. All right. Let's see. Here you go, folks. Right. Manholes, retrieval as well, and then also any type of trucking equipment as well. Okay. All right, and then like we talked about, above ground storage tank. So let's move on to page 2 now. We have all the definitions down, and now let's go through what the NCCER book says. Okay, so now on page 2 of the NCCER book, and if you look in the left-hand side, bullet points, right? Some examples of confined spaces. What are we talking about? Manholes, boilers, trenches, tunnels, sewers, underground utility vaults, pipelines, pits, air ducts, and processing vessels, right? A lot of the ones that we just answered, okay, that we just talked about. Anybody who's not familiar, and I think we talked about this a little bit last week, you'll see the process vessel right underneath in the picture as well. And then in addition to that, we already talked about the definition of a permit required confined space, and a confined space or a non-permit required confined space, right? And then one of the 4 requirements that can make it a permit required confined space, which is there in illustrations 1.1.1 and then sections 1.1.2. And then I think last week when we're wrapping some of this up, we also talked about the tripod, and there's your tripod, right? Your ladder, confined space. You see the employees going in with a welding torch, and as you see, it's going to be gas welding, right? So they're probably doing one of 2 things. It may be argon cutting, or it may be gas welding with gas, oxygen, and acetylene. And as you remember, a few weeks ago, we talked about all the oxygen and acetylene hazards, okay? So so I want to advise you of a few things right here before we go on. I'm going to bring you to the confined space standard in general industry, okay? So let me go here, and let me go to Google for us. And this is what I'm doing, folks. I'm going 1910.146, which is the confined space standard in construction. And I want to show you a couple of things, okay? And let me know if you're aware of this or not aware of this. So now I'm going to look up the words mechanical retrieval. I think you might have just seen it. So let me go ahead and find this for us now. Okay, we talked about this a few weeks ago, and I know some of you are newer on the line now. Look at this paragraph right here, folks. Where is it? Excuse me. Okay, right there. Okay. A mechanical retrieval shall be available to retrieve personnel from vertical type permitted spaces more than 5 feet. So how many times, and this is for permit required confined space, not a non-permit required confined space, right? So let's say if this space that we're looking at here in illustration in figure 2 on page 3, if that's a permit required confined space, that employee's got the ladder in there, right, for access, they got ventilation. But if it's still considered a permit required confined space, we've got to have a mechanical retrieval device. So what are we talking about? We're talking about a tripod, right? In most cases, that we'd be using just in case we needed to retrieve that person and pull them out. Okay. Does everybody see what that standard is just now that we talked about? There you go, right there, folks. Okay. It's right there in front of you. Okay, great. Okay. So let's go ahead and let me show you one more thing right here since we're here, folks. Let's see. Give me 1 second. I want to see if this is the standard that something's in. Okay, no, it's something we're going to talk about in a little bit later. Okay, so if you look at your right-hand side, right, page 1.1.2, we talk about different entry permits and what the responsibilities are that have to be on it. We talked last week. I think last week I had y'all look at the sample permit too. Is that correct, folks? Can y'all chime in and let me know if you hear me okay? And let me know if last week I had y'all look at the permit. Was that last week? On page 4 and 5 of module 2? Okay, good. Okay, good. All right. So does everybody have their permit? Does everybody have their own permit for their company? Let me know if you've ever filled out a permit before. Okay, good. Okay, so most of you have, right? Most of you have. So what we're going to do is this: is that I'm going to go ahead and also when I upload the confined space sheet to you, I'm also going to upload a permit which has everything that OSHA requires to have on it. The only thing that we've added to that permit is the GPS coordinates, okay, which it really is now is recommended, but especially if you're in an area where it may be where it's remote or kind of isolated, you definitely want to make sure that you have GPS instructions on there because it's often the easiest way for emergency responders to get to us. Okay. Okay. Good. All right. So on the break, if you want to take a look at that permit, and like I said, I'm gonna upload one the next day or two for you, the one that we use as well. Okay. So let's go ahead and keep on going. So let's talk about the entry spacer as well, right? Again, like we're talking about, this is everything that we putting it on there is the results of all the atmospheric testing, the name and signature of the entry supervisor, right? The list of all workers, everybody who's going to be in the space, who the attendant is, who the supervisor is, any rescue procedures, what the work procedures are, and also any energy isolation controls, all right, that we'd be putting in place also. So when I send you the form, we've got one that's much more detailed. And like I said, it's all the information that OSHA requires, kind of like this one, but I will send it to you so you have it, okay? And then hazards associated with working in a confined space, right? Number one, folks, always, always, always is going to be atmospheric hazard, okay? That's going to absolutely be always the first hazard involved. Does anybody know what kind of, when the people who use multi-gas detectors or multi-gas sensors out there, can you tell me, do you know what you use? If you use a Draeger, MSA, Orion, Industrial Scientific, Ray Systems, if you know what you use, can you just chime it in so kind of let people know? Okay, so I got a Draeger and Altair, MSA, Orion. Okay, yeah, I use a lot of Ray Systems. I use a lot of multi-ray, ultra-rays, area rays. It's different types of products made by the same company, RAE, that you see on the bottom left. Okay. All right, good. Okay, so different processes, right, that could make the atmosphere oxygen deficient. Could be cutting, welding, rusting of metal, infiltration of any type of external fumes or exhaust. Maybe let's say if there's a welding operation going on outside of a tank, maybe if somebody's got some kind of motorized equipment outside of a tank is a perfect example as well. Also, the breaking down of plants or garbage, oxygen missing with other gases as well. And then what's going to happen, right? There's all your signs. And we talked about this last week, fast breathing, mental judgment, extreme emotional reaction, unusual fatigue, nausea, vomiting, inability to move your body freely, loss of consciousness, death, right? Folks, anybody who was online when we did the small book, the small basic orientation, safety orientation book, do you see how much of this is a repeat of the small book now when it comes to confined space? Yeah, yeah. It's it tends to be a good repeat. But let me tell you something, folks. And the reason it is because it's such a significant hazard. Okay, so and then obviously physical hazards, right? Things like what, like electrical shock from tools, right? Purging hazards, purging. I know we talked about last week and the week before about purging with nitrogen, right? Perfect example. That's usually tends to be the gas of choice because what it does is it makes an inerted atmosphere. Basically, it depletes the oxygen level in the air. Therefore, it will not allow for fire to start or sustain because it doesn't have enough oxygen. Okay, but it also affects us, obviously, right? Then hazards like fallen objects, engulfment, extreme temperatures, hot and cold, noise. Okay, also slick or wet surfaces, and then moving parts as well. Okay. And like I said, look, folks, this is what I'm gonna do. Is I know that a lot of us talk about confined space a good bit. Some of us aren't, are a little bit less experienced than others. But read, what I'm gonna ask you to do is that during, after we wrap up tonight or wrap up this week, I'm gonna ask you to go ahead and read the responsibilities of the entrance and the attendant supervisor. You see it; it's all bullet pointed. So just read it. Make sure you're up to speed on it. And I read it on that other sheet too. So you're gonna see it on the on the review when you're watching the videos from the previous sessions as well. Okay. Okay, good. And then items like first of all, I do want to point this out though, with the number one responsibility. Okay. And they do not have it in order as far as NCCER. So I do want to be clear about this. Let me go back to my presentation. I want to be really clear about this, folks. Look at this sheet that we did. This is a direct extract, all of this, of 1910-146, okay? And look at what the number one safety responsibility is for all the entrance attendant and supervisor. And that's know the hazards and know what can go wrong, okay? And that's out of the standard. And actually, it's worded just a bit differently. It's actually know the hazards of the space. And let me pull it up for you because I'm really adamant about us knowing our responsibilities, especially that one, because one of the questions that I first ask people when we're trained is what's the number one duty? And the word that you're looking for, folks, is if you word search it. Anybody who's seen me word search, and all I'm doing is Control F, and I'm word searching the document. Okay, so I'm going through the word duties because that's the word that I know that it's under. Okay, so let's see. Okay, so look, folks, here you go. Duties of entrance, right? Look at the number one, H1. Know the hazards, right, that may be faced during entry, including information on the mode, signs, and symptoms and consequences of exposure, right? Number one. Let me go to the next one. Duties of attendants now, right? Know the hazards, that may be faced during entry, including the information, mode, signs, symptoms, and consequences of exposure. Again, right? Same thing. That's I1, and that's for attendants. And then let's get to the supervisor. Duties of the supervisor. Look at your first responsibility right here. Same responsibility, okay? So like I said, I'm pretty adamant that we know it because it's number one for a reason, right? Why is it number one? First of all, we got to know what can go wrong, right? We got to know what can go wrong in the space because if not, how are we even going to recognize a hazard? Okay? And that means that we've had to been trained of what can go possibly wrong in that space, all right? Okay. So let's keep on going, and then you got rescue workers. Let me just talk about rescue workers really quickly. OSHA does not speak much about rescue workers, so I definitely want to address that. I'm on page 10 of Module 2, folks. And then there's two types of rescuers, right? Entry and non-entry rescuers. And the non-entry rescuers, what are we talking about, right? Is that they have to be trained to stay outside the space. Okay, non-entry workers. A non-entry rescue worker cannot enter the space unless that person's been relieved of being the attendant and then is authorized to go in. Okay, basically a supervisor would be doing that, and that's in case of emergency. Because remember, that's when we're going to be using a rescue, right? Also, it's usually done by the attendant. In normal cases, non-entry rescue, and it's the type of winches and tripods, right, and whatever we need to pull the employees safely out of the space. And then also rescue workers have the following responsibilities as well, right? Know the hazards of the confined spaces, know the proper use of personal protective equipment, practice rescue operations, right, and get to know their rescue procedures. Also, at least one person. It says be trained in first aid and CPR, folks, but the OSHA standard for rescue says that at least one person has to be trained in first aid and CPR. And then also know the company's confined space rescue program as well. Okay, we have to know our own safety program, right? If not, again, we're at possible risk. Okay, and then let's talk about monitoring and testing. Give me one moment, folks. I'm going to pull up a screen for you. Okay. Okay, so let's see where this is. Let's see. Okay, folks, I know a few of you, I know I've showed you this before, I think a few weeks ago. Can y'all read that okay? Is that clear to y'all? Can y'all see the difference between the red print and the black print? Can y'all see that all right? Okay, good. Okay, so let me show you what this is, folks, all right? This is one of the forms that I'm sending out to you as well. All we did here, if you go back to page 6, excuse me, as you see that air meter on page 6. Okay, and basically what we've done here is that everything that you see that is in black is what we want the meter to read, right? 20.8, some people say 20.9, the jury's out on that, and that's fine. Difference of 0.1%. Also, we want our LEL to be at 0, preferably, our H2S to be at 0 parts per million, and our CO to be at 0 parts per million, preferably, okay? That's ideal, is what we want to be in that black. If this is 28.8 or 20.9, either way, you're fine. Now, everything that you see in red is what's the permissible exposure limits by OSHA. We are allowed to work in an atmosphere and enter an atmosphere that is anywhere between 19.5% and 22.5%, 23.5% oxygen. Okay, less than 10% lower explosive limit (LEL). H2S less than 10%. I'm sorry, 10 parts per million. And then carbon monoxide less than 35 to 50 parts per million, depending on the application and where the exposure is. Okay, so those are the numbers that we must stay below. The black is the numbers where we want to be. Okay, for anybody who's not familiar, folks, I want to kind of point this out. Is that excuse me one second. Okay, is that oxygen and LEL is read in percentages. This VOC should be parts per million. Sorry about that. Oxygen and LEL are read in percentages. Everything else, H2S, volatile organic compounds, that's like chemicals like toluene, xylene, benzene, okay, that may be a little bit more hazardous. Carbon monoxide, all of these must be read in parts per million, and that's how they're read on the meter, okay? Oxygen and LEL are read in percentages, okay? Let's see. So I'm going back now, folks. I'm going back into page 11, 1.5.1. That's where we left off. That's basically an illustration of what maybe a screen would look like on a monitoring piece of equipment. We're going to get into it. We got into it before, air quality. We're going to get into it again. Okay. I'm sorry. Can you hear me now? I see a couple of you said that you couldn't hear me. Okay, good. Okay, sorry. I don't know if it was me looking down. I might have been squeezing on the mic. I'm not sure. So sorry about that, folks. Okay. So did you hear me say that the black was ideal and the red is the permissible exposure limits for OSHA? Okay, good. Maybe the only thing you missed, and then I said that oxygen and LEL are red in percentages. Everything else, this should be VOC. VOC is volatile organic compounds. Should be red in parts per million. H2S is red in parts per million. Carbon monoxide, carbon dioxide, sulfur dioxide, sulfur trioxide, benzene are all red in parts per million. And then when they're significant enough, like benzene, they'll often be red in parts per billion as well. Okay, so if anybody missed it, that's what you missed. So sorry about that. Okay, and then ventilation, right? Well, what are we talking about, right? Is that the air in a confined space, obviously it can be hazardous to our health, right? It can be oxygen deficient, or it may be a toxic chemical. So what do we have to do? We have to ventilate, right? The first and preferred means of ventilation is actually blowing air in. So if you go back to page, I think it was page 3. Yes, on page 3, you'll see the blower in there with the hose line. It's on figure 2 at the top of page 3. What's happening is that's not air being extracted out. That's actually air being blown into the space, okay? So that's what you're looking at. Also, in addition to air ventilation being blown in, and then we may be having air that may be extracted out as well. But we have to remember, right, that just because there's air being blown into the space, it doesn't mean that it's actually being ventilated, okay? So we actually want to make sure that we're actually getting ventilating in order to remove the toxins as well. And now what am I talking about? Now I'm talking about extraction, right? Basically an air change, changing the levels of air in the space. And then also personal protective equipment, our PPE, right? It could be a full body harness, lifelines, air purifying respirators, air supplied respirators. So I know we talked about the respirators last week when we talked about the GHS. And we'll talk about them again as we go. You'll see them in various modules, all right? Did everybody catch that last week, the ones that are online and were online last week, as far as air supplied respirators and air purifying respirators? Okay, good. Okay, great, folks. And like I said, you'll see that over and over and over again, okay? And then additional controls as well. And what are we talking about? Basically locking out and tagging out equipment, right? Getting rid of any type of mechanical energy, anything in movement, anything can possibly move, anything you can slam shut, open shut, something, anything that can harm an employee. Electrical, hydraulic, air pressure, chemical, biological, radiological, okay, locking out any source of energy that may potentially harm an employee, okay? And then, of course, communication, right? Making sure that everybody's able to communicate in one way or another. So what are we talking about? It could be air horns, it could be bells, whistles, radio, screaming if it works, light signals. It could be tapping on pieces of metal. So as long as we can have effective communication, and all the employees know what the what the communication means, and then we're fine. Okay, and then we're getting to page 1.5. Talk about training, right? And basically what happens, we have to be trained for the job that we do, right? Like we said, we have to be trained in the job that we do. We also have to be trained for the hazards associated with the job and in the area that we're going to do it in. Okay. So that pretty much covers that part of module 2. We're going to move on to page 15. And we're actually making really good time tonight. So what we're probably going to do is I think I'm going to get a little aggressive tonight, folks, to kind of pick up the pace. And I want to try to really push to get us through modules 3 and module 2 and module 3. Is everybody okay with that? If we push a little harder tonight, still get you out on time, get you to the test a lot quicker. Y'all good to go? Okay. All right. If anybody needs me to slow down, I will. But y'all will see that it's going to flow pretty smoothly. Okay. If I see that we get beat up on excavations, and then we'll deal with it. And this is pretty much where we left off last week anyway. I just kind of wanted to do a kind of recap of that confined space, just because it's such a critical issue. Okay. Okay. So now what are we talking about, right? We're talking. You saw your trade terms on the left hand side, right? I'm going to show you. I'd rather show you on the computer what all the different um, shoring, benching, right, sloping, what they all look like. They're in the book, and then I'm also going to show you in the OSHA on the OSHA website as well. Okay, so let's talk about this first. First of all, folks, um, angle of repose, right? What are we talking about? It's the greatest angle above the horizontal place at which the material will adjust without sliding, right? So basically, what are we talking about is that we're just basically putting the material in areas where they won't possibly slide back in. I'm going to tell you this. I've never heard it called the angle of repose in the field out of all the years that I've been working. Has anybody, do me a favor, have anybody who's out there, have you ever worked around an excavation and people talking about the angle of repose? It doesn't even sound natural to say it, does it? Okay, good. As long as I'm not the only weirdo in the group and we're all weirdos, I'm good with it, okay? Just so you know. Okay, and then we're going to talk about benching. So we'll get to that. Carbonation, what is it? It's a chemical process, right? Where carbon accumulates and causes a breakdown of surrounding materials like dirt, okay? So basically we're talking about the buildup of carbon that may structurally affect now the environment that we're going to be working in. And then compression strength is the ability of soil, right, to hold a heavy weight. So basically, what weight are we talking about? Can it hold the weight of an excavator? Once we start digging out of the earth, can it take the surcharge, or can it take the weight in the near environment? Okay. Cross braces. You'll see. I'm going to show you some examples of cross braces in here. Basically, horizontal members. This trench box right here. Excuse me. I'm sorry. If you look at page 15 at the top, you'll see the trench box, and those are cross members inside of a trench box. They may be there like that, or they may be in hydraulic shoring as well. Folks, I want to tell you, I'm so messed up right now. I tried to put my finger on the page 15 and move my cursor around on that page. So, instead of on the computer. So, obviously you can tell we might have problems today after the break. All right. In addition to that, also hydration, right? What are we talking about? It's a chemical process where water or liquids are going to accumulate and they can cause breakdown in materials. So basically it becomes waterlogged, right? The material becomes waterlogged and it starts to affect the structural integrity of the dirt or the clay. Oxidation as well, same thing, where oxygen accumulates and now it starts affecting the dirt. Protective systems, folks, are going to be any method that we're using in order to protect employees in excavation. It's going to include shields, shoring, okay, trench boxes, cross braces, benching. All of that is going to be counted in there, okay. And then you'll see shielding, soaring, uprights, whalers. I'm going to show you all that because I'd rather show you the pictures on it. And then subsidence, what are we talking about? It's a depression in the earth, right? That's caused by an unbalanced stress on the soil around an excavation. So basically, we may be putting too much weight on one side of excavation, and it may cause some issues. And I'm going to show you some pictures of the issues that it can cause. So if you look at your right-hand side on page 15, you're looking at different excavations there, right? Hazards and trench boxes. The biggest thing is I can tell you this. And I don't see it, fortunately, I've only seen it about 1 or 2 times, but I often see it when the trench box isn't in place. Have any of you ever seen an excavation taking place? Tell me if you've ever seen an excavator while it's working. Okay, so a couple of you have. I'll tell you my biggest concern is when an excavator works and the employee stays in the excavation, and the excavation starts digging out. A lot of times they feel they have to measure to get to a certain footage. And you know what? I'm going to tell you my opinion on it. That employee has no business being inside that excavation while that shovel's going down there. Would you agree with that? Okay, good. All right, folks. Okay, so there's some pictures of some excavations. If you look at the next page, safety hazards associated with excavations. So what are we talking about, right? What hazards? Look at the top of page 16, folks, on Module 2. And what are we talking about? Cave-ins due to trench failure, falls from workers that are too close to the end of the trench, flooding from broken sewer lines or water mains, also electrical shock, where somebody might strike an electrical cable when we're excavating, or maybe we've introduced the electrical source, confined space or atmospheric hazards. Right now we're talking about air quality, toxic liquid or gases that could be leaking from nearby facilities or pipes in the area in which we're in. Maybe we barely nicked the gas line, or some type of other hazardous material that's in a pipeline. Also, automobile traffic when excavation's near, and then falling dirt or rocks where somebody may be harmed as well. Okay. All right. So I see we got another sign on. So we're at the bottom of page 16 in the field safety book, folks. Okay. At the bottom left, you'll see the type of soils, and you'll see the total number of failures. Okay, by soil type, and there's the failure. There's failures by soil type, and I'm gonna come back to that in just a little bit. Okay, just to let you know. And then if you look at the table on your right hand side, on the right page, page 17. There's your description of what soil textures are, okay, and what their characteristics are when you try to manipulate them in order to tell their type. So I'm going to send you some videos tonight. I'm going to send you some, tonight or tomorrow, some OSHA videos. I may even send them on a break. I might have you, let me step back a second. I did not have y'all watch the 2 OSHA videos yet on excavations, did I? Let me show you what I'm talking about, okay? These two videos here on excavation and trenching, I don't think I had you watch them yet. Is that correct, folks? Going once, going twice. Okay. All right. I got mixed signals on it, so I'm going to send them just in case again, folks. I don't think you've watched them yet. Okay. I'm going to send you these 2. Has anybody watched them? Maybe even if I didn't give it to you, has anybody watched them yet? Okay. What I'm gonna do is I'm gonna send you both of those. But okay, both of those are really good videos. Okay, and as a matter of fact, what we might even do, I might send you. Do me a favor. Let me know if you have a. Let me know if you have the capability of watching videos from whether you're logging on from your phone tonight or whether you're logging on from the internet or from your computer. Let me know if you have access to videos tonight. If you needed to watch them. Okay, I might have y'all go to. Okay, good. I tell you what I'm gonna do is this is what we'll probably do is that when we take the break, we're gonna take the break at 7:30. I'm probably gonna have you watch both of those videos, and what we're gonna do is this: is both videos are like a total of they're on YouTube, but let me show you the easiest way to get to them, folks. Okay, easiest thing to do is this. Okay, and just watch this, and I'll send you the link anyway. Is go to Google and Google OSHA vTools. Okay. Normally, I would actually do them after hours, but I think what we're going to do is we're going to do them during the break. If I'm going to give you a little bit more time to do them, and I'll tell you why. Because excavations are so few of us have experience around excavations, and it's such a great hazard that I think I'd rather you watch them, and then let's just kind of push through that tonight, and then we'll see how we do on Module 3. If we don't get to it, we don't get to it. But I'm kind of concerned about excavations just because it's such a crucial topic. Okay. All right. So what you do is you go to Osha V Tools. It'll be this. Don't worry about the advertisement stuff. Okay. It'll be this one right here, the one that says Prevention Videos V Tools, and it says Osha right here. When you click on it, it's going to bring you straight to the page. And then here they are right here. A couple of you asked if they're on YouTube. They are on YouTube. But if you go here and you click on it, it'll bring you to it, and you can play it. And you can also click here to get to YouTube as well. If you, excuse me, you can also click here. Okay. I know a few of you hadn't been on previously. These webinars, they're really not that great for streaming video. So that's why I'm not playing it on here for you. But like I said, I'll give you enough time on the break to watch them both. Okay. That one's 9 minutes. And this one is, I think this one's 11 minutes or 12 minutes, something like that. Let's see. 11 minutes. So that way we'll do that and then a 10-minute break, and it'll get everybody off and you'll be able to watch the videos, and then we'll reconvene and talk about it. Okay. Okay. So let me keep on going. So now let's talk about different collapses and how, if a trench is going to collapse, what's going to look like. Has anybody ever been exposed? Has anybody ever seen a trench collapse or anything that's out there tonight? Yeah, most of you haven't. I'm going to tell you, I've seen them, but I've usually seen them on the. I've usually seen them after the fact. Okay, I haven't seen one during the collapse, but yeah, definitely not something very nice. Okay, so if you look at your top of your page 18, you'll look there, and they'll start talking about cracking and fissuring. Okay, if you look on the top left, and then so let's talk about it a little bit, right? So what are we talking about? Workers, when can they be buried, right? When one edge of the trench caves in or the other edge. Also, when one or both walls slide in, okay, or both walls, they shear away, okay? So those are a lot of examples. I'll show you on the next page a lot of this as well. And then also, these conditions, right, different order of seriousness, right? Disturbed soil for previous excavation or ground. Also, trench intersections where large corners, of earth can break away. This is where we're usually at greatest risk, okay? A narrow waterway causing heavy equipment to be too close to the edge of the trench. Basically, we don't have enough area to work, so we're putting heavy equipment too close to the end of the trench. Also, vibrations from other construction equipment, or even the equipment we're using, right? The excavators that we're using, maybe our dump trucks may be vibrating a lot. Also, increased subsurface water. Maybe water that might accumulate or something that could flood out the excavation or damage it, or even the quality of dirt that's still being held that we did not cut into. And then also drying of exposed trench walls that all of a sudden now they cause moisture, right, that binds together. And basically, if you take humidity, dryness, we can start breaking into them. Almost like if you look in the top picture of the crack in the bank, it could start causing issues like that, okay? Or even where you see the wet clay and looms where they slab off in the bottom left picture. And then inclined layers of soil dipping into the trench as well. All right, so if you look at your right-hand side, page 19, these are the safeguards that we have to have in place, right, in order to make sure that employee safety is protected. Things we have to do, right? Never enter an excavation without the approval of the competent person on site. You remember what I said, right? If we have a protective system, if we dig greater than 5 feet, we have to implement a protective system, or even less than 5 feet if the competent person deems it necessary, okay? So at 5 feet, now we have to have a protective system in place. The protective system, like we talked earlier, it has to be designed by a qualified person, but it has to be supervised by a competent person. The reason it's got to be supervised by a competent person is because that competent person has to be able to take corrective actions if necessary in order to protect the trench and protect or the excavation, and to protect the employees' well-being. Also, never enter in an excavation, right, until the excavation has been inspected and for any required permits, and it's got to be inspected on the daily time. And also, anytime we have any type of change in the environment, like rain, frost, severe vibration, or any type of heavy equipment, if we have maybe a piece of earth that breaks off or something, anytime any condition changes on or near that excavation, or every shift, or every day, really, the competent person has to do an inspection. So let me ask you a question. We're all familiar that scaffolds must be inspected on a daily basis by a competent person prior to use. Are we all in agreement with that? Okay, good. So do excavations, okay? Okay, good. So let's see. Let's keep on going. Of course, wearing our PPE, right? Our hat, glasses, boots, gloves, or respirators if necessary. I want to say this about respirators. You heard me say it last week. You heard me say it a few weeks ago. We cannot wear a respirator of any sort. Air purifying, half face, full face, air supplied, SCBA, SAR, right? Any of those that we talked about, and like I said, we'll be talking about them again, without have been medically evaluated and fit tested. We must have been fit tested within the last year. Have an active fit card that's less than a year old. Okay, and then we can only use the respirators that we've been fit tested for. Okay, so if you've been fit tested for a 3M half face and a Scott full face or a Draeger full face, that's all you can wear. Okay, even to the point where dust masks. If dust masks are required, we must go through all the respirator training and fit testing. If they are voluntary, and then it kind of changes the game a little bit, and there's a little bit more lax regulations on the employer. Okay, so let's keep on going. Get out of the trench right immediately if water starts to accumulate, because we don't know how fast it's going to accumulate, and if it's rising water from the water table or from any type of leaking equipment. Also, not walking under any loads that are being handled by power shovel, derrick, hoist, excavator, right? When we're talking about power shovel. Also staying clear of any vehicle that's being loaded, being alert, watching and listening for possible dangers, not walking above or below any coworker, right, on a slope or benched excavation wall. I'll show you that in a second. And then also barricading access to excavations, right, to prevent other pedestrians and vehicles as well from getting too close. We're going to talk about surcharge after the videos when we come back, and I think this will make a lot more sense, okay, for anybody who it's not making sense for yet. Also check with our supervisors to see if workers entering the excavation need excavation permits, right? And then ladders, ramps, or any type of other excess material. We have to be able to reach a ladder within 25 feet, okay? If you look at the picture right here, when you watch this video, it's the trenching video. It's going to even tell us that, and they're going to show in this illustration that basically this is like a 50-foot trench here, and the ladder had to be stationed in the middle. Best practice is to have two, but if I'm on one side of this trench, the maximum I can travel to get to a ladder is 25 feet. It doesn't mean there has to be a ladder every 25 feet. It means that the maximum travel distance has to be 25 feet. So let's say if this is a 50-foot trench, I can put one, in theory, I can put one ladder in the middle. And as long as I can reach it from this end of the trench to here within 25 feet and reach it from here to here within 25 feet, it would be still compliant with OSHA. Now, if this is a 55 or a 60-foot trench, now I have to travel 30 feet. Now I've exceeded my 25 feet. Now it's not compliant anymore. Does that make sense? Okay, good. Okay, if anybody needs any clarification on that, let me know, and I'll make a slide on it if necessary. Okay. So, and you'll see it in the video as well, so it'll make sense. Now look at your next page, and I'm about to get us to these videos. Okay, folks. Look at your next picture on the left-hand side, and just look at those six, right? Tension cracks, sliding, subsidence and bulging, right? Toppling, heaving where it's being pushed or squeezed down and coming up the bottom, and then boiling as well, often with water or water tables, okay? So this is what I'm going to do. I'm going to pause here because I think it's almost 7:30 already. Yeah, it's almost 7:30 already. I'm going to pause here. And let's do this. Is everybody okay on where to find these videos, you're Googling OSHA V tools, come in here to prevention, right? To the V tools, and right here, these two, okay? So let's do this, y'all. It'll give you all a break, right? It'll let me get some stuff ready. I'm looking at right now, we may very well, everybody got on early. I may crawfish on what I told you instead of trying to get too aggressive on 3, because I think I'd rather kind of spend a little bit more time on excavation. Are y'all cool with that? Because if not, we're going to be pushing through with heavy equipment. I mean, we might move on to 3, but it's going to be, yeah, it's going to be close, okay? We may or may not. We'll see. I'm going to look at it during the break and right now, and we may push through. It's not that many pages. Okay, so let's do this, folks. Go ahead and take a break. Let's reconvene. And this is what I'll say. 8 o'clock, let's kick it off hard, okay? Even if you're not on, I'm going to roll on without you just so I can get everybody off by 10 minutes or 10 minutes to 9 or 5 minutes to 9 and give everybody a break. One quick question before I let you go. We may have to record Thursday's session tomorrow night because of a couple things we got going on. Come to find out, there may be somewhere I may have to go, and also we may have some. Come to find out that we may have some issues going on here with our coax cable in our area. I'm not sure yet about this. If we decide to do that, if we have to do it, I'm probably going to go on live tomorrow night and record it so everybody can still watch it on a scheduled Thursday. Does anybody want to jump on tomorrow night instead of Thursday night if it's available tomorrow? Okay. What about the rest of y'all? Are y'all okay? Everybody okay? Y'all okay with that? If we have to do that, I just want to make sure. I know we told everybody Tuesday and Thursday, so I don't want to I don't want to mess anybody up either. Okay. Overall, okay. Okay. So let's talk about it, and then let's talk about it and see, because I don't want to put anybody out. Okay. So if we have to do some makeup time or something like that, I will too. But like I said, I'll probably jump on tomorrow, do it anyway, and then if we need to jump on Thursday or Friday, we'll figure it out with whomever we need to figure out with as well. Okay. And the ones of y'all who told me it may be an issue, if y'all don't mind, I'll probably call y'all tonight or in the morning just to talk to you about it. Okay. All right. Cool. Okay. So 8 o'clock, and we kick it off, folks. All right. Gives us 29 minutes. All right. Thank you. I'll talk to y'all then. Okay. Hey everybody. Okay, I'm back on now. I see that almost everybody made it back on. I think we're just waiting on one. So we were going to go ahead and move forward. All right. So let's talk for a couple minutes. First of all, who got to see both videos in their entirety? Can y'all? Okay, good. Okay, so let me ask you, of those of you that saw them, was that did it kind of help to understand soil classifications just a little bit better? Okay, good, great. And then you see how they're talking about evacuating the space, right? Making sure that we have a ladder within 25 feet, and then more importantly, and the biggest thing I wanted to get out of it was the one for soil classifications. You saw how they did the test, right, on rolling the dirt and the panometer test as well. So yeah, no, really, really good, informative. Little tough to keep track of the second one, right? So much technical information. I would definitely recommend this, folks. Take that second one and watch it again. Okay, actually, take them both and watch it again. But especially the one on soil classifications, and you'll see how much every time you'll see how much more it makes sense and how much more material you get out of it. Okay. All right, great. So let's do this. Let's go back to page 20. Let's go back to page 20, and we're looking at all the different failures, right? One second, folks. I'm sorry. Give me one moment. Sorry about that. Okay, great, folks. Okay, sorry about that. Okay, so let's go through them, right? Now what we're looking at is we're looking at 6 different definitions of failures, okay? So now we have tension cracks, right? Now we have the sliding, which is basically what you saw in the failure, right? Of the one that you saw where the employees were stuck in the trench. Also, you got toppling, you got bulging as well, and then heaving and boiling. Now, normally it's going to be one of 2 reasons why this happens. One, of course, is going to be water, right? Introducing water into the environment. And the second one is putting any type of surcharge on that ground. And what am I talking about when I'm talking about an excavation surcharge? Is do something for me, folks. Go back to the first page of excavations, which I think was page 15 or something like that. Let me check. Page 15. And now you see, if you look at page 15, look at figure 9. And now when you look at all those excavators, right, in that trench, especially look at the one on the bottom. That's probably the best illustration of it. And if you look, that's surcharge, right? Where the excavation's open, they're all surcharge, but that's probably the best example of it, because you see where the tracks are so close to the excavation. They're going to be, right, because of the operation necessary to do them. But what it's basically doing is putting a surcharge or putting weight. But not only is that surcharge, what else is surcharge? People, right? Where the spoil piles or the dirt are, all of that is also surcharge. So anybody who, and I think one of the videos talked about the spoil piles. Let me go to the internet, okay? All right, folks, anytime I'm talking about spoil piles, I'm talking about this. I'm talking about the dirt, okay? Or here's a temporary spoils. Here's a perfect example. So anything that we're excavating out of the earth and we're putting out on the outside of the excavation is called the spoils, okay? This is the standard. The standard says that we have to have at least 2 feet here between the spoil and the excavation. So here, the spoil and the excavation, we have to have at least 2 feet or more before anything can be there. So it's not 2 feet from the crown of the spoil. It's 2 feet from the base of the spoil, okay? So the first 2 feet have to be perfectly clear all the way around. Or I say perfect clear. Have to be clear of no weight all the way around. So basically cannot look like this, all right? And the reason being is because we want to make sure that that's going to minimize the risk of anything falling in. It's taking and it's putting less surcharge on the very end of the excavation, like here and here. All right. And also, if employees have to walk, they actually have some space to walk around. Okay. So just items that I want you to keep in mind. So folks, look, we've been talking about a few things, right? Does anybody know the difference? Let me know yes or no. Do you know the difference between an excavation and a trench? Okay. So let me give you the definition, right, folks, for the excavation trench. It's actually, believe it or not, it's going to go more to depth versus width. So let's do this, right? This is the best way. Let me tell you this before we go, and it'll make sense once I show you the pictures. All trenches will be excavations. Excavation is anytime we're digging out of the earth, okay? So all trenches will be excavations, but not all excavations will be trenches. The reason is that a trench is going to be twice its depth compared to the width, okay? So let me go to the definition now for OSHA, okay? All right, so this is what I'm talking about right here. So the OSHA definition excavation is anytime we cut into the earth, right? Now, what's a trench? A trench is right here. A trench is, is narrow, okay, and it's going to be deeper than wide, okay. So let me show you an example of what I'm talking about. Okay, so this will be an excavation. This will be a trench. because it's deeper than it is wide. Okay. Now, this is what will happen though, is that the deepest we can go on an excavation, the widest we can go on an excavation is 15 feet. And on let me get this straight again. The widest we can go on a trench is 15 feet, okay? So here you go. So if this is less than 15 feet wide, it would be considered a trench. And it has to be deeper than it is wider, okay? Now, once we get to, let's say, 15 feet, and now we get past 15 feet, it's just going to be an excavation. Okay, what happens is it's always an excavation, right? But the trench, anytime somebody tells me a trench, the first question I have is, how wide was it? So if they tell me that it was 15 feet wide or less, then yes, they're probably correct that it probably wasn't a trench as long as it was deeper than it was wide. Okay, but if it's wider than 15 feet, it's no longer going to be a trench. Now it's going to be an excavation, and the difference being that they have more room to work in there. And that's really the greatest difference, okay? So does that make sense, folks? Are y'all okay with that? Okay, good. Okay. All right. So okay, so just to answer your question, let me clarify one more time, right? A trench is going to be deeper than it is wide. Okay, good. Okay, now the widest it can be is it can be anywhere from whatever, right? Let's say the width of a shovel. Let's say 2 feet, right? Maybe 18 inches, depending on the shovel, or it may be as wide as 15 feet, but it will not exceed 15 feet. Once it exceeds that, it will no longer be a trench. It'll still be an excavation, but it won't be a trench. They're all excavations. Okay, good. Okay, good. All right, so let's move on, okay? Okay, so if you look back at your book now, you'll see that 2-foot spall pile, and that's why they have it barricaded off, okay? So let's go ahead and talk about it now. What are we looking at, right? You know, ladders, right? Typical safety preventions that we have to take, right? We have to be able to access the ladder within 25 feet if that excavation is 4 feet or deeper. If the excavation is deeper than 5 feet or deeper, now we have to have a protective system in place, okay? Also, now I'm at ladders. Like I said, if it's 4 feet deep, we're going to put a ladder in. We have to reach it within 25 feet. All right. Once that ladder's in, we're going to use the same rules. Now it's got to extend 3 feet or 3 rungs above its uppermost contact point, which basically be in the ground. Okay. And then ladders have to be non-conductive side rails. Okay, while working around electrical equipment. So what are we talking about? Our traditional fiberglass ladders, right? 2 or more ladders have to be used anytime that employees have to traffic more than 25 feet. I will tell you this, that unofficially, and I can just tell you from what from the understanding that I've had from people who've had contact with OSHA, I've never had it happen. So it's unofficially is what I can tell you at this point, which is if an employee, even if it's less than 25 feet of travel to that ladder, like in this picture, right? Even if it's less than 25 feet, pretty much the rule of thumb is up to 3 employees for one ladder. If you have more than 3 employees, you may want to start considering a second ladder in there, especially if you have 5, 6, 7 employees. I would definitely put at least a second ladder in. The reason being is that if some type of emergency ensues and there has to be an immediate evacuation, you have to think about how long it will take those employees to exit that space, okay, or that excavation. All right. So let me go ahead and move on. If I'm looking at page now 22 and 23, here's the definitions of sloping, shielding, shoring systems. Okay, you see it all there. Everybody see your trench box there, right? It was actually classified as a shield, and I'm sorry, as a shoring device. And let me take you to. I want to take you straight to page. You saw most of that in the video, so that's why I'm going to pass it up and let you read it if you want to read it. Go to page 25. I want to go ahead, 24 and 25. And I think last week we talked about this. I just want to go ahead and show it to you one last time. If you look, you'll see the different types of excavations and the different types of protective systems if we're using excavation for a protective system, okay? So if you look, there you have on page 24 and 25, you have your different excavations and what kind of cuts we can make on a type A soil at 2.42, B soil at 2.43, and almost no one classifies anything as A soil nowadays. Okay, best practices are classified as B, C, and in Louisiana, I'd call it quicksand down here. Okay, no, just kidding, right? Everything down in Louisiana is pretty much a C, for the majority of it. And then if you look at it, look down at the benching and sloping, and you got three different things going on. First of all, you got a slope, right? Like if you look at figure 17, 18, and 20 are all slopes. Look all the way down at the bottom at the multiple bench. So you see multiple benches like steps. And if you look right above that, you'll see a simple bench. Simple bench is basically a slope with one bench level. Okay. Now, let me ask you folks, anybody who's familiar, look at the multiple bench at the very bottom and look at the simple bench. And you see it shows maximum 4 feet. And look at the multiple bench at the bottom. It's 4 feet over 4 feet over 4 feet over 4 feet maximum to get out. The reason that's done is because, correct me if I'm wrong, y'all, and agree with me, we need a ladder if we have to climb greater than 4 feet. Are we in agreement with that? Good. Okay. So this is what happens, right? Is if you make each bench level 4 feet or less, you do not need a ladder. Because employees can climb from bench level 1 to bench level 2 to bench level 3 to bench level 4, bench level 5, and get their way out. Does that make sense? Everybody with me on that? So let me show you. So let me show you a picture of that. Okay. Okay, good. It seems like everybody's got it. So great. So here you go. Right. So let me show you here. Let me show you actually a decent one. Okay, so let's go with this one right here. As long as this does not exceed 4 feet, this does not exceed 4 feet. It can be less, it just cannot be more. This does not exceed 4 feet. This does not exceed 4 feet. Then an employee can, in theory, can get up 4 feet, come up here, walk on this bench, get up, walk, 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 and that is a proper exit for a bench system. Okay. So just so you know how it works, okay, folks? So if anybody's got any questions on it, let me know. Same thing with here, but normally on a slope, usually it's 4. And then depending on the pitch of the slope, if the employee can't get out, you may have to lay a ladder down. And so an employee can almost use it like a chicken ladder or like a ladder just laying on the ground for traction to be able to walk up like cleats, okay? All right. So let me go ahead and move on. That's all of our protective systems. And then then we're to the summary, folks. Okay. So let me ask you, we are going to go ahead and move on because the work zone safety is actually going to be really fast. You're going to see how much of it's been repetitious already, with the exception of the signage. Let me ask you, folks, does anybody have any questions about excavations that I need to answer? Let me know either way. Let me know you're okay or throw in an answer. But either way, give me an answer if you wouldn't mind. Okay, good, folks. All right, great. And just so you know, we're putting together some type of fact sheet, something, okay, to give you for excavation. We usually do the fact sheets, but now we've decided that we want to show these protective systems, and we're kind of doing some illustrations. Those are not for NCCER test purposes, just so you know. Those are going to be for your personal reference. So those will probably take us a few weeks to get to. Okay. All right, great. Okay, so if you wouldn't mind, go to excuse me one second. Okay, go to page. Let's go to module 3, page 1, and you're going to see that we're going to get out of module 3, page 1. Good. Okay. Okay. So let's look at this and talk for this for a minute, right? As you notice, there's only one trade term, right? That's how easy this I keep on wanting to say standard. This section is going to be. And what is it? Conspicuous location, right? What are we talking about? Easily noticeable, right? We're going to be talking about a lot of warning signs, a lot of danger signs, and instructional signs as well. Okay, directional signs. Okay, so of course, first and foremost, what's the most common or what's the most serious sign, right? Is going to be danger sign, right? So we're going to talk about them in order of significance. Okay, danger signs being number one, right? What are we talking about? High voltage, no smoking, no matches, open lights, right? Basically anything around a flammable or combustible, right? And then also danger, keep away. Maybe an area where employees do not need to be. All right, why? Somebody might get hurt, somebody might get killed, right? It might cost the company money, all of the above. Okay, if you go to page 2, you'll see that we'll start talking about different signs, right? Obviously, you have your orange cones, traffic control. Let me ask you a question, folks. What are the difference between yellow signs, like you see the caution signs, right? And and orange signs that we see on the roads. Let me give you an example, right? Okay, why are some signs yellow like this? And then why are some signs orange like this? Little trivia question for you. So tell me what you think. I'm going to wait. I'm going to read off the answers to you as well, okay? Okay, good. Okay, so let me tell you, we've got a few not sures, right? All right, I'm gonna a couple people had one person had the right answer in there, so let me go ahead and talk about it for a minute. This is what'll happen, right? Is first of all, it depends on which one goes best with your construction outfit, so you can choose. Just kidding, just kidding. All right, this is what happens. Orange signs like these, folks, these are temporary cautions. That means that they're there because of the work going on, but they will eventually go away. All right. Yellow signs like these are permanent cautions. These are after construction. These are permanent cautions that exist on that roadway. You got it? So yellow is permanent, right? Permanent caution exists unless they can engineer out the hazard. Orange is a temporary hazard. Okay. And these will go away once construction is complete. Okay. All right, good. All right, so let's keep on going, right? So different types of signs, right? Danger, do not enter. First of all, I want you to take particular attention to the danger, do not enter, then the danger, the machine starts automatically. We'll see that the danger signs are going to be red, white, and black, okay? White background, black lettering, right? Red silhouette, okay? So all this is standardized. And then look at our caution signs. Hearing protection required, right? Open door slowly. Yellow background, black outline now. Okay, black outline, and then black text, right? Only. And then we'll get into signs like our stop sign, of course, right? What's it telling us? That's a permanent caution. It's telling us that there's a stop sign coming up. All right, now you see your radiation hazard on the right-hand side, and then also your biological hazard as well, okay? Folks, one thing I'll ask you is this. These signs right here, definitely get used to what these signs look like because they'll probably make some really good quiz or test questions, okay? And then if we flip pages, so look, we're going to have 3 types of signs, y'all, okay? We have danger signs, okay? I mean, we have more than 3, but the 3 main types are danger signs. Number 2 are caution. Number 3 is informational signs. So now what are we talking about, right? No admittance. I'm on page 4, folks, of module 3 for anybody who's not there yet. No admittance, no trespassing, employees only. Okay, all of those are informational signs, right? And then we may have traffic and housekeeping signs. Those are usually going to be black and white again. It's going to be like dead end, right, of an aisle or passageway. Okay, it could be location of trash cans, location in the width of aisles, rooms and passageways, stairways, as far as risers, directions of borders, drinking fountains, food dispensers, all those types of signs as well. Okay. And then we have our fire signs, right? Exit, exit route, also fire alarm. And the perfect description for all of those signs are directional signs. They're directing us where the fire extinguisher is, and they're directing us where the exits are. Okay. And then if you look on the right-hand side, of course, slow-moving vehicle. What are we talking about? An orange sign, right? With a orange triangle with a red border. Okay. And then we have like accident prevention tags as well. Anything to do with our health, right? Eye wash station, first aid station. Okay, first aid kit, folks. All of those will wind up being green and white. Okay, so even your first aid. So let me show you what I'm talking about, right? Okay, so let's do this instead. Let me go to first aid kit sign. There you go, folks. Now it's been standardized, and our first aid kit signs should be green and white. So should our eye wash signs as well. Okay, muster stations. Let me ask you a question. Who's noticed items like this, like fire first aid going from red to green in your workplace? Maybe you've noticed things like this, like a muster station sign. Muster station signs like this now being green in the workplace. Let me know if you've seen them. If you haven't seen them, okay. So some of you haven't, right? A couple of you have. Okay, great. Okay, so now you know, right? If it's informational for us, like I said, accident prevention, muster, safety, eye wash station, like I said, first aid. We know they're going to be green and white now. Okay. All right, great. Now flip to page 6, and these are your 6 traditional types of safety tags now. Okay. So we have some that have startup instructions. Other ones just clearly tell us do not operate. But not only is it do not operate, we should be putting why we're not operating it as well. Okay, so that's always a good practice to also know why we're not operating it. And then out of order, of course, I would also say the same thing, right? Let's say perfect examples out of order might be tagging a piece of equipment out of do not operate. Okay. I'm going to tell you, if I'm going to go with one, I'm going to go with the do not operate, okay? And I'm going to use it to tag out, let's say, a forklift that may have bad brakes, right, or may have a hydraulic leak. I'm going to go ahead and pull it and also pull the key on it as well. And then authorized personnel only, right? Only qualified employees can use it. And then live wire examples, and then other ones, right? Not removing the tag, and then denoting on it what the hazard is. Okay. And then also identifying barricades and barriers, right? Perfect example on your bottom left. So what are we talking about, right? We're talking about different barricades, barriers. I'm in the first column, the left column of page 7, folks. Just so you know, railings, right, are used across wall openings or as barriers around floor openings, like we know, to prevent falls. Warning barricades alert workers and to hazards, right? But provide no real protection. It's really a soft barricade. It's not a physical barricade. Well, we have two. I'm sorry. We have a hard barricade, and then we'll have a soft barricade, right? Like tape or caution, or warning lines, stuff like that. Now look at the tape or rope, right? It's also standardized by color. So what are we talking about now? Red. What are we talking about? Danger, right? No one can enter the area, with a red warning barricade, right? Usually it's nobody can enter except the employees that are authorized to work in that area. Yellow means caution, right? You can enter the area with a yellow barricade, but you have to know what the hazard is. A lot of times what will happen nowadays in common practice is that red will mean that it's usually only the employees that are allowed to work in that area or near or adjacent to that hazard. Yellow usually means other employees can come in as well if necessary. Okay, of course, after knowing the precautions and knowing the hazards they may be exposed to. And then yellow and reddish purple indicate radiation hazards. I'm going to show you these in the internet in just a few minutes. Okay, and then barricades often used where pipe and welds, right, where they're doing X-ray testing. And then, and then of course protective barricades, right? They can provide a visual warning, and a physical, block as well. Okay, and then blinking lights in place of barricades so they can be seen at night also is a great practice. And then covering holes. I'm at the top of page 8, covering holes on the ground, right, to make sure that employees aren't exposed to hazards. So if you go back to figure 12, you'll see where they show. Look at figure 12E at the bottom. You see where they covered the hole, right, or where the excavation's going, or the manhole where you see where the barricade is. Okay, so my biggest thing is I tell people, get a hard barricade, get a physical parade barricade, plywood, okay, fencing, something that's going to physically bar somebody from being able to get close to the excavation. And then if you look, before we move on, I want to show you different things in different colors, caution tape. Okay. All right, so here you go, right? Here's different caution tape colors that we're normally used to seeing, and this is what the color codes stand for. Okay, we're talking about right now, right? Yellow and purple. Yellow with purple writing for radiation hazards, fire protection equipment, red and white. Okay, right? Physical hazards, black. Yellow with black writing on them, caution. A lot of times red will also be red with black writing. It'll be do not enter danger. I'll show you in just a second. Okay, so there you go, right there. See caution, right? Do not enter danger. Okay, so now you see, sewer, right? Sewer hazards, or safety first aid, and green. Okay, blue is going to be for defective machinery, or maybe for utilities below. Okay, so just different hazard caution tapes for you. So all I did, folks, like I said, caution tape colors, right? And then it'll take you through different ones. Okay, so just some examples for you as well. Okay, so let me go ahead and move on from there. Let's see, 1 second. Okay, so let's go to page 10. And let me go through the training terms here. Center of gravity. What are we talking about, right? Where the weight's evenly distributed, so that something's not falling over or tipping over, or we're not falling over or tipping over. The flagger, who we're talking about, the person, right? Either the sign person or the flagger person. That employee has to be adequately trained as well to do their job. Okay, one of the greater hazard jobs that we have, as a matter of fact, because of the risk of traffic control and struck by hazards. Also, pinch points, being caught between two moving parts, or one moving part and a still part. And then anytime you see the initials TTC, and when it comes to roadway, you're talking about temporary traffic control. So what are we talking about? Orange, right? We're talking about orange tape, right? Orange cones, okay? K-walls. Let me show you a few things for anybody who's not familiar. So let's go to construction K-walls. Okay, the K-wall is this right here, folks. These walls that you see here, right there, that's considered a K. They call that a K-wall, okay? But let me show you like all these that you see here, okay? So you have permanent ones, and then let's go to temporary traffic devices. Okay, so here we go, folks, right? Perfect example right here. There you go. Those are K-walls. In construction, those are just temporary. Let's see. Okay, then you got your barrels, of course, right? Your barrel, for anybody who's not familiar, that's a weight that's at the bottom of this barrel, holding it down. Okay, our caution signs are diamond, right? They're also going to be black with orange with a black ring, and then the black sign and what the information is, right? Perfect examples here, what the sign's saying, right? What it's telling us it's doing. Okay, so like I said, it's all traffic, it's all temporary. Here you go, and there's an example of it. So let me show you folks. Let me know. I want to make sure everybody's okay with this. It's called MUTCD. Okay, it stands for Municipal Uniform Traffic Code Devices. So let me show you this website. Okay, so it's MUTCD. Anybody who has a flagger, you're going to be training them to this standard. Okay, when you have employees doing traffic cone devices, you're going to be training them to this standard. So I'm going here. Can y'all see this? Okay, or y'all can y'all still see my screen? Good. Okay, good. Okay, so I'm coming here to MUTCD. All right, and when you come through here, what'll happen is they'll have I went down. I don't know if you noticed. Let me show you where I went. I went down way down here at the bottom of the. It says training. Okay. Now, when I come to training, what'll happen is I can't remember the number for traffic control. Let me see. I want to say it was 6, but let's see. Let me show you what this is, folks. Okay. This is these are PowerPoints that you can use to train your employees. Okay. And this one goes on to talk about stuff that you're going to see right now that we're going to talk about, like downstream, upstream. I'm going to show you what I'm talking about. Vest, what type of vest, signage, okay, flagger assistance. Okay, you see like the minimum size. You'll see this in just a second. Minimum size of a sign has to be 18 by 18. Minimum size of a flag has to be 24 by 24 with a 12-inch stick. So it's 36 inches of stick, 24 inches on the flag, and then 12 inches left on the stick, okay? All of this is standardized, just so you know. It's got to be the right size so it can be seen from a universal amount of feet under appropriate conditions, okay? So great PowerPoints there that you have, all free, all done by the federal government. Anytime we train traffic control folks, these are all the PowerPoints that we use, and you just don't have to use them all. You use what's relative to your work environment, okay? So so let me go ahead and y'all got that on how to get to it. Let me go back to it just in case anybody needs help, right? So all I'm doing is I'm coming here as you see at the bottom, training, right? And then it's pulling all these PowerPoints up for me right here. Okay. And like I said, when I download them, I've got them all on my computer already. Like I said, it's got different ones. It tells you what the signs are. Let me see if I can pull one more set for you. Give me 1 second. Let's see. Okay, so here you go, folks. Oh, sorry, wrong one. So different PowerPoints right there. Oh, excuse me, it's the wrong one. Sorry, y'all. Right here. Okay, different ones. There you go. So here's 5, here's 6. Okay, and different PowerPoints like that for the MUTCD. Okay, so feel free to look through them. They're great. They have all flagger tips in there, types of signs, highway signs, construction. You'd be surprised how standardized we are. Anybody who has done the 510 with me or anybody in our office, did we ever talk about how standardized we are? We talked about how standardized we are on the interstate, right? So let me go back and let me ask you a couple questions, right? And then we're going to move on. I'm going to shut us down in about the next 10, 15 minutes, folks. We got 3 pages to go, just so you know, okay? Let me ask you a question, folks. Tell me who's familiar with, if we're on the highway, if we're in the interstate, what color sign do we look for if we are looking for, let's say, a rest stop, a restaurant, okay, a hotel, okay, yeah, blue, right? Absolutely. All right, what if we're looking for a national park? What color are we looking for? Yep, absolutely, brown, right? And so, absolutely. So let me tell you where all this comes from, right? All this comes from, folks, from all this stuff right now that I'm downloading, all the municipal code devices. That's where all that information is, okay? So if you ever need it, that's where it is, okay? And then what I'll do is I'll make sure I email everybody that page so you have it, okay? Okay, so let me keep going. Okay, so now, like we said, right, it's all standardized. So let's talk about flagger responsibilities. I'm on page 11. Oh, first of all, look at the sign. Look at typical. You see typical use of barricades down at the bottom. Let me show you something really quickly, okay? For anybody who's not familiar, I do want to show you this. Let's see. Anybody who's not familiar with barricade signs, you see the barricade we have down there in the bottom left? Let me show you something really quickly, okay? Let's see. Okay, so this is what I'm talking about, right? Barricade signs like this. Okay, tell me if you, tell me if you know this or not. You see these lines right here? If these lines go from the top right to the bottom left, that means that traffic's going to come this way around the sign. Okay, so now you see this one right here where it goes from the top right and it angles down to the bottom right. I mean, top left down to angle right. That tells me that the traffic's going to come this way. Okay, so it always put the lines always push you out on the direction that you need to go. Were y'all familiar with that? And that's for yellow or for yellow. Yeah, excuse me, orange or yellow, either one. Okay. So if you ever see them, and I'll show you after, like dead end, it'll have it both ways. So let's see, dead end. Trying to find the one left to right. I'll pull it up right here. Something like this, right? They'll usually be straight, or it'll tell you, it'll one go left and the other one go right. Okay. So so different signs like that. And I'll pull that up for y'all and show y'all next class, just so you have a better idea of it as well. Okay. Okay. So let's go ahead and keep on moving on. So what's a flagger? What's the responsibilities? Right. Clearly and firmly, right, and politely give specific instructions. Move quickly to avoid danger. Use signal devices, right, like paddles and flags, and we're about to talk about those and the standardized sizes on them. Apply safe traffic control practices, right, sometimes in stressful or emergency conditions as well. It might have to be. Identify unsafe traffic situations and warn workers in time to avoid injury. So one of the main responsibilities of that flagger or that signal person is to advise other employees when there's a potential hazard. Okay, they don't just jump out the way. You start jumping out the way, ringing a bell, a whistle, hitting the air horn, whatever you have to do. Okay, if you look at the next page, look at page 12, and here are your standardized signs. This is what we just saw, right? That's what we just saw on the preferred method of paddle sloping. Folks, I'm going to be opening a couple things on the website. Don't worry about the website. I'm just downloading some files because I want to try to show you something before we leave. Okay. And then if you look at, there's your paddles. Like I said, your paddles have to be 18 by 18. They must. They also have to be of reflective material. It can't be of plain material. Okay, where people cannot identify them. All right. On one side of the paddle, it'll be stop. On one side of the paddle, it'll be slow. Has anybody ever seen the ones that look like toys? They're really small, looking like a 12-inch paddle? Has anybody ever seen those? You probably don't see them much anymore. You don't see them much anymore, but you used to see them all the time before. So they've pretty much, and what happens is all this stuff got standardized, right? So that's why we don't see it anymore. Okay. All right. And then also, what happens is to stop traffic, what's the employee doing? They're putting their hand out, right? They're putting their hand straight out, or with the stop sign goes up and one hand goes out, okay? The belief is that you're supposed to assume that the person doesn't know what the sign means, so that's why you're also doing a hand signal, okay? So that's why you're also doing a hand signal, okay? And then, in addition to that, if you look, it says to let traffic proceed. What do? Slow, and then the hand, right? But look at the traffic control. That the flag goes down in a 45-degree angle, and then you're whisking your hand to tell people to keep on going through. And then to alert people or slow them down in traffic, right? In the bottom, you see the one on the left, right? Things that we do, like pushing the hand down, like slow down, slow down. The flag, I got to be honest with you. waving the flag down, I don't think gets people's adequate attention. I think that if you're going to be flagging with one hand, you should be waving them down, and with the other hand, start pushing down or waving down to advise them that that they're going too fast. Okay. All right. So those are your different signs. And then if you look at the right hand page, right, page 13, right, always observe the following guidelines when driving equipment on public roads. So, you know, these are different safety tips, right? When we're driving equipment on public roads, I'm at the left-hand side of bullet points. Drive slowly, of course, right? Not speeding. Know the differences that it takes to safely stop. Allowing extra time, right, to enter traffic. So we don't want to just be jumping in. We're not in a vehicle, of course, so it's going to be slower, and we have to proceed with more caution. Know and follow the traffic control patterns. Traveling with our lights on, especially in dim visibility or foggy conditions. Use proper warning signals and flags. Also securing all the attachments and loose gears, right? If we have a crane, make sure that there are no loose components or equipment moving around. Perfect example. Also turn cautiously, right, to allow for extensions and attachments to be able to turn as well. Make sure if you have anything that swings out on the back end, you want to make sure that we don't put anybody at risk by too much swing out also. Knowing the turning radius, that's what I was talking about, if the turn equipment and the swing radius. Okay, and then knowing and obeying all state and federal laws, right? And then always follow the guidelines for driving equipment on the job site, right? Hey, never drive a machine in a congested area, right? Around people, have spot or move the people out the way. If we can't move the employees out the way, don't operate the machine. Okay. Be sure that everyone's in the clear while backing up, connecting, or moving attachments. Never move buckets or shovels over the heads of any type of workers. If you can't see the surroundings area clearly from the operator's seat, and then what do? You get a spotter, right? Get a spotter on the radio, get a spotter on the flag, right? What you can visually see. Make for an all clear warning or horn before you move. Signal a forward move with 2 blasts of the horn. Signal reverse with 3 blasts of the horn. Okay, and then yield to the right of way of any other equipment or pedestrians. Maintain a safe distance from any other vehicles, either if you're moving in a convoy or just independently. When moving, also keep the equipment in gear at all times. Right, don't coast. And then maintain a ground speed consistent with the ground conditions, right? So are we on ice conditions, foggy conditions, okay, any type of raining conditions, making sure that we're traveling at a safe and adequate speed, and then also know where the overhead electrical and power lines are, which is one of the greatest risks, okay? So then last of all, also making sure that we know where any buried lines are. How do we know? We're going to call one call, right? So let me show you really quickly, folks. You know, what I'm going to do is this, right? I'm going to go and I'm going to call 811. And anybody who's not familiar, I'm going to show you the same thing. 811 color code. So much of what we do is coded out, y'all. So here you go. Okay. So here's a perfect example. Okay. So there you go. Red is electric. This is when they come and spray paint your lawn, right? And or flag it out. They'll flag it out, or they'll use an eco-friendly paint. Okay. And what are we talking about? We're talking about electric's red, right? Because red's most important. Gas and oil is yellow. Communications, right? Telephone lines, copper, fiber optic are orange. Blue for water, green for sewer. Temporary survey would be pink. Any type of irrigation systems are going to be yellow, and then the proposed evacuation is going to be white. I'm talking about paint or flag, folks, either one. Okay, so here's a perfect example right there. You know, so when you see all that, you know, how many of you realized that all those colored flags meant something else, or paint on the ground? Anybody? Okay, so I'm trying to find. I got pictures of some site drainage that we had done. Actually, a friend of mine did, and I took a picture of his. So I'm going to see. Let's see. I'm going to see if I can get you a color. Show you one that's been painted out and stuff. Here it is right here. Look, perfect example. It'd be something like that. Okay. Y'all probably just thought that was graffiti, huh? The kids just painting on the street and on the grass, huh? All right, folks. So you got that as well, right? And then, and that's it. That's all the heavy equipment, y'all. Like I said, I knew we were going to go through that fast. Let me show you one or two things. Y'all got another minute or two, just so I can show you a couple of things from the PowerPoints we downloaded. Okay. So here you go, folks. So if you're looking at, let's say, a canal, right, and the canal only goes to the right, this is what you'll see. You'll see 4 or 5 or 6 of these lined up, and they're all going to be in that same direction. That's telling you can only go to the right. Okay. If you see the one on the left, right here, it's going to tell you can only go to the left. Or they may wind up having 3 to the left and then 3 on this side over here to the right. You know, just if they need more visibility or it's low lighting. Or we may have some of these lined up. Okay, and these are telling us we can go left, or we can, remember, because I told you when it goes down, right? It tells you can go left or you can go right. So this one tells me I can only go to the right. This one tells me I can only go to the left, and this one tells me I can go both ways. Okay, so that's a perfect example. And like I said, everything is standardized. Okay, so all these PowerPoints that you see in there that I told you about, check them out. I mean, they're really, really, really a great resource. Okay. So let me just see what else I have in there for you. See if there's anything else I want to show you for tonight. Anything from the size of the street lights, okay, to the size of the highway signs above our heads. It's all like when I tell you it's standardized, I mean, we're way more standardized than we realize, okay? So, so just different hazards like this, okay? Okay, so just check it out, folks. And like I said, we're going to give you some more information, more than what's in the NCCER, because like I said, our thing's not just about passing the test, right? It's also about all of us having and being armed with as much information. So there you go. If you need any of your information, right, your information calls, you know, you got your blue signs, right? There you go. Okay. So check those out if y'all get a chance. I'm also going to send y'all a couple of links for videos. And then this is what I'm going to do, folks, is I know a couple of y'all were concerned. Most of y'all said it was okay to roll tomorrow. And then I'm going to have it recorded on Thursday. You can watch. You won't even have to watch it during that time span. You can watch it at any time. We're going to record it. Same thing we've done with every other one. I know a few of you had to catch up on some videos. What we've done is we actually almost finished editing them all. What we did is we cut out the breaks. We cut out some of the long pauses, okay, to kind of help everybody out in the delays. That way you don't have to be fast forwarded through it. We took care of it for you. So those, let's see, Pat, Monique, Carlos, we'll get you guys up to speed on those. Let me see who else. Tiffany. Okay, yeah, and it looks like Tiffany probably. And James, we'll get you caught up on yours. And then we're going to have them all, and we're going to send you all a passcode to be able to log into YouTube and check them out. We're actually doing it on YouTube instead of on the LMS because, excuse me, not the LMS, instead of on Go to Training, because you'll be able to stream a lot easier and from anywhere and not have to sign in. You just have to log into the channel for us, okay? And that's it, folks. So let's go ahead and shut it down for the night. Anybody got any questions? You got any comments? Anything you want me to answer? Any concerns? Got the Powerball numbers that I can have, so none of us have to do this anymore? Okay. All right, folks. Well, look, y'all have a great night, okay? Y'all have a great night. Pat, I'm going to call you in about 30 minutes. Isaac, can you give me about 5 minutes, 5 or 10 minutes to call you? Okay, thank y'all, everybody else. All right, y'all have a great night, folks. And then, like I said, we sent y'all all the answer sheets and all that, so that way you can get up to the test. I think we sent out the answer sheets for test book 2. I'm sorry, the last book, Technology, and we'll get y'all up to speed to that. Beverly and Monique, I think y'all too, and who else? I think Carlos were some of the last ones to come in. So if y'all need us to help you catch up on anything, let us know. But I'm going to send you the video links in the next couple of days. And that way, if you want to start hitting it hard, you can. And I know most of y'all are close. So if you need to come in, we can get you up to speed as well, okay? Okay, great, everybody. Thank you so much. Have a great night. And then Isaac will call you in 10. Pat, I'll call you in 30, okay? Thank y'all. Have a good night.